In this video I'm going to go through the 2015 HSC, and I'm going to go through this pretty quickly. I'm not going to go through a whole lot of detailed answers, at least not in this video. Okay, so first question is, which of the following has both magnitude and direction? Oh yeah, it's not scalar, it's vectors, right? Vectors don't have the direction. Okay, question 2, which would be suitable for PET bottles? That is going to be blow molding. How does an increase in velocity affect potential and kinetic energy? Okay, so if we increase velocity, the formula for kinetic energy is half mv squared. So as v goes up, kinetic energy goes up. So it's going to be something where kinetic energy increases and potential energy is going to decrease. So if we have an increase in velocity, it's traveling on a horizontal road. So because it's a horizontal road, it maintains. So that's going to be B. So there's no option for decrease there on potential energy. Okay, good question. I like this question. A pictorial view of a block is shown. Which one is the view in orthogonal projection to third angle projection? Yeah, so that symbol there, the target and the flag is a less than symbol, is the third angle projection, which means that the top view is on top. So which of the views where the top view is on top? So here, this is the front view, this is the front view, this is the front view. So this one cannot be correct because the top view is not on top here. So if we're looking from that front view, it's going to make the letter Z, not the letter N. So it's going to be one of either A or B. The question is it a French flag or a Dutch flag? Well, from that direction, we have a line near it, a line a little bit further, a line further away, and then the final way. So that's not this one, it's this one. We've got a line near it, a line a little bit further, and then a line furthest away. So the answer is A. Okay, this is a sprocket. Which heat treatment is most suitable for hardening teeth? Okay, so we've got flame heating or induction heating. Now, I like both of those. I think both of those are reasonable for hardening one part of the material. Now, why don't we harden the whole thing with quenching? The reason is because we need, for something like a sprocket or gears, we need the inside to be durable. We need it to be ductile, so we want it to be tough. So we only want the hardness on the outside. Now, we can use flame hardening or induction hardening. They both get the same effects. The benefit of induction hardening is it can be automated. So I'm going to say that it's going to be induction hardening, then quenching. We good? C? 5C?
Why quenching?
Yep. Because slow cooling will give you normalized grain. Okay, so yeah, which process combines a data carrier wave in the form of a television signal? So when we're combining information, what's that called? No, that's modulation. Multiplexing is when we combine multiple signals. Yeah, when we have multiple signals on the same line. Modulation is when we take the signal and our carrier and we combine them, yeah? Whereas multiplexing is where we put multiple signals on the same. Is that good? You're going to tell me if I get any of these wrong and we'll hit, yeah. Okay, this question, okay, so what we need to do is we need to multiply 100 by the distance here. So here the number is 300, right? 300 divided by 6 is 50. Here it's 100 by 1 divided by 3 is 30, so, or 33 and a third. So this is, B is already better. Here,
by the distance and divide by the distance to x.
Excellent. We're multiplying the mass by the distance, then dividing by the distance to x is what Sergey said, and that's correct. So this is 300 divided by 4, so it's going to be 750. This one here is going to be 300 divided by 3 is going to be 100, so B is correct. Okay. 8. Which statement best describes the difference between cast iron and steel? Okay, well, so the main difference we talk about is that cast iron has more carbon, right? So D, cast iron has a high percentage of carbon. But steel, well, steel doesn't contain graphite. Cast iron often has graphite. Cast iron does not have a higher tensile strength. It has good compressive strength, but it's not as good. We sacrifice tensile strength for hardness and castability. Steel has higher compressive strength. No, not true. Okay, so this is rectification. What kind of rectification? This is half wave. Yeah. So how do we get smooth? How do we get? This is full wave. Sorry, a student said half, and I have to correct that. Half would be just if we just ignored the bottom part. Yeah, so if we had something look like that, that would be half wave rectification. We have full wave rectification, And then smooth rectification. What device do we use to get smooth rectification? Excellent. Okay, this question I think I gave you. It's a bit contentious, but I gave it to you, I think, in a trial. Is okay, so what material are we going to use for a heat sink? Now, a heat sink needs to be a good thermal conductor. So which of these materials are good thermal conductors? Steel and aluminium. Okay, so which one is realistic? Rolling or die casting? Die casting, yeah, because rolling is for large sections, things like steel train tracks and steel beams. Okay, so the correct answer there is aluminium die casting. Okay. So logic gates, we've gone over this specific question. In order for this to work, we have a not dot on this AND gate. So that means that we need both of these to be off in order for it to work. So switch 1 and 2 both have to be off. Sorry, that's a NOR gate. I apologize, I think I misspoke. That's a NOR gate. So the not dot on the OR, but nevertheless the point remains true that these both have to be off in order for the not dot to switch it around and convert it. And this one, switch 3, needs to be on. So that that means we need to have off, off, on. So that's C. Okay, this is an interesting question. I remember seeing this question, and at the time I hadn't taught resistance as heavily as I used to. As I currently do. So when we're doing parallel resistance, this would be, if each of these is 10, that's going to be 10, 20, 30. In this case here, we're going to have 1 on 10 plus 1 on 10 plus 1 on 10, right, is going to be 3 on 10. Flip that, right? So that's going to be 10 on 3, which is 3.3. That's too low. So this one here, we're going to have these two in series, so that's going to be 1 on 20, 1 on 20 and 1 on 10. We combine those together, we're going to get 3 on 20. 3 on 20, flip it, is going to be 6.6, so that's no good. Let's look at this one here. So let's do this situation first. So we're going to have 1 on 10 plus 1 on 10 is 2 on 10. Flip that, 2 on 10 becomes 10 on 2. 10 divided by 2 is 5. So this section here is a resistance of 5 ohms. This one here is 10 plus 5 is 15. D is... Okay, so we have to do this thing in parallel. So we're going to have, this is 20 ohms. Yeah, this here is the same as having a 20 ohm resistor. And that's 10 ohms. So what we're going to have is 1 on 20 plus 1 on 10, which I believe is 3 on 20. These are in series, so that just count that as a 20 ohms on the top and 10 ohms on the bottom. Yeah. So we're going to have 1 on 20 plus 1 on 10. Right, which is 3 over 20, which flip it is 6.66. Okay. Yeah.
Because it's still in the top part was in series, you consider that as one big resistor and then consider it parallel.
Yeah. Okay. So, in which direction does a reaction face act as a roller support? Okay. So if we have 3 different kinds of reaction. We have fixed reactions, pinned reactions, and rollers. Rollers are the simplest. They can only offer one kind of reaction, which is it parallel or perpendicular? Perpendicular. So that's D. Right, now a lot of people, typically it's going to be just vertical, but sometimes we have things like cranes and gantries where it is actually, we have everything turned on its side, and so it's going to be horizontal. So that's why we have to say perpendicular. Okay, so perpendicular to the direction that rolls. This is a good question. Okay, it shows the end of a spark plug. What are the properties of the area shown? Well, now the area shown is a ceramic. So ceramics, what do they have? Yeah, okay, so they're good insulators, or also known as, they have resistivity. Yeah, insulating resistivity is the same thing. Excellent. That's exactly right. Ceramics have the refractory property, which means that they maintain their properties at high temperatures. So the answer is C.
Why does it need to be That's a
spark plug. It's a spark plug, so that the spark isn't firing all the time. The spark needs to fire at a very precise interval. That's exactly right. Okay. So, I think I gave this to you in the trial. Okay, so which best represents the composition of new large passenger aircraft. So here we're thinking things like the A380 and the Dreamliner 787. Both of those are made predominantly of composites. So it's either going to be B or C. So what is the remaining material going to be?
B.
Yeah, aluminium. So B is correct. Okay.
What would be the aluminium material?
Aluminium, there's still enough material. So we use composites where possible, but a lot of the frame, for instance, still needs the strength of aluminium.
Glare
So
is a composite.
glare is a composite. Yes,
It
it's
has aluminium in it.
exactly right. Glass, laminate, reinforce, aluminium, resin, epoxy. Yeah. Okay. And I'm not sure what the composite is made of in the 787, but I know that that's a feature, is that they're predominantly composites.
Carbon fiber, maybe.
There definitely is carbon fiber. So, for instance, the propeller blades are carbon fiber. But I'll leave that as research for you guys to send to me to the group chat. Okay, so this is in third angle projection, which means this is on top. And what we're going to look at is which of these cables is drawn at true length. Okay, so we've looked at this question when we studied true length recently. Can anyone tell me which cable is a true length? One. Excellent, yep. So it's only a true length in this view. Also worth noting that this is also, the rod is also a true length because it's a dot. Excellent. Okay, which of the following could cause fatigue cracking in a metal?
Cyclical applied load.
Excellent, that is exactly right. A cyclically applied load. Okay, so a static tensile load just means that there's a constant tension in the object. Well, no, we're not talking. Necking is when we increase the load past its ultimate tensile strength, and it will start necking. But if we just had a rod, let's say we had a chain, for instance, that was just constantly under tension, it constantly had a weight on it.
Yeah.
That's not going to cause cracking, right? It's okay. Substantial shock load. Right, so all of a sudden, chunk.
Something added.
Yeah, something's been added. Yeah, so that's a substantial shock load. A high compression load is the opposite of a tensile load. So we have, say, a beam that's constantly being compressed. Now, but cyclically applied loads is things like planes, where the wings are constantly being elevated. I don't want to say flapping, but they're constantly being lifted and dropped as the air pressure changes. And that sort of cyclical load, which is slowly applied and released stresses, does create fatigue cracking. Okay, and it's a big deal. Okay, what are two advantages? Another similar thing is if we heat an object, we heat and cool it regularly. That's another thing that creates creates a similar kind of cracking. Okay. Two properties of using powder forming processes. Okay, well, I like talking about powder forming. Sintering is another term. What's advantage? Okay, well, low material waste and high density. There is low material waste, that's true. High porosity and low material waste, I like that better. Low porosity and high tensile strength, no. Okay, high quality surface finish, yep. And tensile strength, Okay, so eliminating the ones that say tensile strength, which one do we like the best as an answer? B, yeah. So,
High porosity because it's like tiny particles.
yeah, that's exactly right, yeah. So, the high porosity, the advantage of that is that it can be self-lubricating, so that we can lubricate from the outside and we know that it will lubricate through to the inside of the parts. Well, so imagine if we have a solid part, right? We try putting some lubricant on we can't get to the inside of those parts. Yeah, whereas on the other hand, if something has porosity, we can lubricate the outside and the lubrication will be distributed throughout the whole part.
That's what it means by self-lubricating. So
Yes.
it have it inside.
Not that it already has it
We
inside.
have to
Yeah.
place it inside and then lubricate.
That's right. Okay, this is a good question. I think I used this in the trial. Okay, so if we're cutting through this hole, so we're going to see the hole and we're going to see the rest of it be sectioned. So it's B or D, but because we can see the hole, it's B. Now, it's not that because we don't section things that we can't see through. There's no way that answer could be right. That would be if we sectioned through here, but then we wouldn't be able to see the hole anymore, right? So, and then this one here is totally wrong. A is the most wrong. Okay, another good question that I like. Okay, so here we have a uniformly distributed load. So we're going to have a small amount of down in the shear. Yeah, so that we've got a force coming up, the 5.1, and then we're going to go spreading that to that 3 kilo, what is it? It's 500 newtons per meter. So over that meter, we're going to